This lesson is going to help us with 6.1 out of our book on ionic bonding. And first thing we want to do is review a little bit about dot diagrams. So we've got 4 dot diagrams we're going to make here. And looking at sodium first, looking at our periodic table here, we find sodium, which is right here. It is in group 1, so we know it has 1 valence electron. That means 1 electron on the outermost energy level, and therefore it's going to have 1 dot for that dot diagram. So we put that up there at the top. We go back and we look at chlorine, and chlorine is right here, and it's in group 17, so it's going to have 7 dots. So we go 1, 2, 3, 4. I'm going to pair them up, 5, 6, and 7. Aluminum, we would find, is in group 13. So it's going to have 3 dots, 1, 2, 3. And nitrogen is going to be in group 15, so it has 5 dots, 1, 2, 3, 4. And then I pair that one up with number 5. So again, we look at the periodic table to help us out with those things. And that should be review. Now, if we take a look, a couple new things, something called a subscript and a superscript. And a subscript, like a submarine, is below. And of the line that you kind of have, that imaginary line that you kind of have on your paper if you're writing, it's going to kind of split that line as this does here. And it's getting written smaller and also below. And then a superscript is going to be written above and behind. But as it says here, that's going to have a number with a positive or a negative sign. So in this case, we've got oxygen, which is a 2-, but we could also have something like magnesium, which would be a 2+, which we'll learn about. So that is what a superscript and a subscript looks like. Next, we're going to look at anions and cations. And we learned the last chapter, we talked about atoms having no charge. Well, an anion or a cation is an atom that has gained or lost electrons and now does have a charge. So anions, by definition, have a negative charge, and those are going to be the nonmetals in the periodic table. And then cations are going to have a positive charge, and they are going to be the metals. We talk about anions kind of being the females, the girls, and we know girls are negative. Just kidding with that, but we go with the girls there, and then the guys are the cations, and we'll talk kind of about how the guys and the girls get together to form a compound. So if we look and get the charge of these different ones, flipping back to our periodic table here, magnesium, we can see is right here. So it's in group 2, so it has 2 electrons. And what it wants to do with those 2 electrons is it wants to get rid of them. And if it gets rid of 2 negative electrons, okay, then it would have a charge of 2+. Why would it have a charge of 2+? Well, magnesium, if it's an atom, has 12 electrons because an atom has no charge. Magnesium has 12 protons because that's its atomic number. If we go back here, atomic number is 12, so that's 12 protons. And if it's an atom, it also has 12 electrons to have no charge. But what it wants to do to become stable is it wants to get rid of 2 of those electrons. So then the 2 that are in the outer energy level would be gone, and then the shell underneath that, the energy level underneath that, would be full. So it wants to lose 2 electrons. If it loses 2 electrons, it had 10, or it has 12 protons. If it loses 2 of the 12 that it has, it now has 10, so what's its charge? 2+. So that's how mathematically we can figure it out, although we're not going to have to do that very often because there's a simpler way to do it. If we look now at bromine, go back up to our periodic table, and we find bromine is over here. It's in group 17, so it has 7 valence electrons in that outer energy level. Remember, the magic number it wants to get to is 8. So the first shell is full with 2, the second and third are shell full with 8, so we have 2, 8, 8. It wants to get to 8. So if it has 7, what it would like to do is it would like to gain 1. And again, if it gains 1 electron, Since electrons are negative, it then would have a charge of 1 minus. So bromine is going to become an anion, and it's going to actually change its name to bromide, just like when girls get married, they change their last name often. So this is going to be, bromine is going to become bromide when it becomes an ion. The positive ions, who are the guys, do not change anything of their name when they become a cation, but when an atom becomes an anion and is negatively charged, it changes the ending of its name to IDE. So now if we look at potassium, potassium is right here. It's in group 1. So it has 1 valence electron, and what it would like to do with that 1, it has 2 choices. It could gain 7 to get to 8, or it could lose 1. Well, it's easier to lose 1 than it is to gain 7. So it's going to lose 1 electron. Electrons are negatively charged. So if it loses a negative electron, it's going to become charged 1 plus. So that's going to become a positive cation with the 1 plus charge. Boron. I find boron right here. It's in group 13, so it has 3 electrons in the outer energy level. Again, it wants to get to 8. The 2 choices are to gain 5 to get to 8, or to lose 3. And boron will lose 3 electrons and then become positively charged with a 3 plus and become a cation. Nitrogen is in group 15, which means it has 5 valence electrons. And therefore, to get to 8, it can lose those 5, or it could gain 3. It's easier to gain 3 than it is to lose 5. Therefore, it's going to become charged 3 minus, because it gained 3 negative electrons. So it becomes charged 3 minus. All right, next thing let's take a look at is not that, this one right here. So let's look then at what happens and why these things form compounds. For ionic compounds, what they want to do is they want to gain or lose electrons to become more stable. And remember, they become stable when their outer energy level is full. So they're trying to get to 8 electrons in that outer shell. Magnesium, you can see right here, has 2 electrons in its outer shell. It has 2 valence electrons. So the dot diagram has 2 dots in its outer shell. If magnesium is going to form a compound with chlorine, we take a look at chlorine here, and chlorine is in group 17, so it has 7 valence electrons. So I'm going to draw these in a different color. Let's put our whole chlorine here in blue, and it has 7, so there's 1, 2, 3, 4, 5, 6, and 7. And you can see it has 1 spot right here that it would like to get an electron. Magnesium has 2 of them it would like to give away. So it could give 1 electron there. The problem is magnesium still is not happy because it's not stable with that 1 in the outer shell. So what we do is it's going to form a compound with 2 chlorine. So if I put my second chlorine in here, and that chlorine also has 1 open spot, this electron can go in there. Now what happens is the magnesium then lost 2 electrons, and we just went over this. If it loses 2 electrons, it becomes charged 2 plus. Each of the 1 chlorine gained 1 electron and became 1 minus charge. So what we have there is our ionic compound, which is magnesium chloride, and we're going to learn how to write this next chapter, or maybe this chapter, MgCl2, and we can see there's 1 magnesium right here, and there's 2 chlorines. So that's where we get the Mg and the Cl, and we have 2 chlorines, so we need a 2 there. If we only have 1 of something, we do not need to put a 1 there. So that's kind of looking down the road there at what we do and how these form ionic compounds. I believe that's the last part of this lesson. Let's take a look. Oh, chemical formulas. So chemical formulas then, like we just wrote down with MgCl2, it tells you how many atoms of each element you have and then what the ratio of those is. So with sodium chloride here, what we have is we've got 1 atom of sodium, and we've got 1 atom of, of chlorine, and we'd have a ratio then of 1 to 1. 1 sodium to 1 chlorine. If we take a look here, we have 2 atoms of hydrogen. We've got 1 atom of sulfur because there's no number here, and we've got 4 atoms of oxygen. So what's our ratio of hydrogen to sulfur to oxygen? It would be a ratio of 2 to 1 to 4. And those numbers I'm getting right here. There's 2, and there's 1, and there's the 4. So that ratio always stays the same. So there's a little review on lesson 6.1. You can go back to and review for a quiz or a test.